We are going to simulate in FEKO a microstrip line. First thing, we have to somehow find the dimensions for the 50 ohm line impedance. For instance, we have this application here online. We are going to try FR4, which is the most common substrate used for RF and microwave. It has here, we can type in the dielectric constant, 4.3. Let's take the height of the substrate to be 1 millimeter and frequency 1 gigahertz. It's a TEM type structure, so it doesn't matter for our purpose. And the impedance that we are going to use is 50, and just type in any length, 10 degrees for instance, it doesn't matter the length. We're interested only in this width here, dW. We type in synthesize and you have this 0.94 millimeters. This is the width of the strip to get 50 ohms here, measured here. Well, once we have these dimensions, the dielectric constant, the height, and the W, the width, we can go to FEKO, CAD FEKO, and create a new model. Then we just inform FEKO the variables. For instance, first variable is F max, maximum frequency. For this case, 1.5 gigahertz. The minimum frequency of our microstrip line is 800 megahertz. Our substrate is going to have 20 millimeters in one direction and 60 millimeters or 6 centimeters in the other direction. The thickness of our substrate is 1 millimeter. The width of our line to get 50 ohm is going to be called W50. 1.94 millimeter. And this last parameter is the offset 3 millimeters. I just forgot, epsilon R is 4.3. Now we are going to construct the structure as we move to construct cuboid, and then we start with our substrate. We picked the base center option. We are going to leave the plane at z equals to 0. So this is supposed to be minus h sub, minus 1 millimeter, as previously defined. Width is our y sub, and d is x sub. Here we see our substrate. Next, we create our media. Right-click dielectric medium. For the sake of make it simple, just type in epsilon R, 4.3. It's frequency independent. It's the simplest case possible. Create. And then you can see that our cuboid here, cuboid, we right click on regions and you just switch it for dielectric 1, which is our FR4. And you can pay attention that it's lossless. We left with 0 loss tangent, so it doesn't have any kind of loss. This is our cuboid. Next, we are going to construct the microstrip line. And the microstrip line, we move to rectangle. The same option here, base center option here. And here we get the Y sub plus offset, which is 3 millimeters. And D is W50. Create. You can see here that the microstrip line is longer than the substrate, which seems to be off, seems to be odd a little bit. The problem here is we need to do this way because we are working with a finite substrate. FEKO, you have the option to operate with an infinite substrate, but in this case we are going to make it a finite, so it's more, it's better. The simulation is more complex, but it pays off because we have better results if we are going to compare with measurements and posterior analysis. You can see here that this rectangle has to be fed somewhere. So we need to place parts here. The part we're going to use is called, you can see here, this edge part. This edge part has something that it requires to be completely embedded on the same substrate. So either we place the part here inside the dielectric, or we can move it outside the substrate. In this case, what you need to do, you need to make a connection, a metallic connection with the ground plane. How we do this? We are going to ask for, well, you can, another thing, you can write down the dimensions, etc. It's doable, you can do it that way, but it's easier using the pick tools of FEKO. And by pick tools, you just type at the same time Shift and Control. And as you can see here, I have available, I'm moving my mouse here. All these pick points, they are available without the need to compute them manually. So how are we going to use this? Well, we move to Construct, Rectangle. And here we need to make a vertical rectangle here. So the work plane should be shifted. You see, like that. It makes sense. We have to keep in mind that this 2D objects, the surfaces, as FEKO call them, they are all the time placed here on this plane. So it's consistent with what you are going to construct here. So then we move to geometry, and the active area is this stressed in yellow. We type in Ctrl Shift, and now using this option here, we pick the middle point, as you see here. Twice, it's done. Now our plane is aligned here. You can see that this shadowed square is showing where the rectangle is going to be constructed. That's exactly what we need. We just need to type in the W and the D variables. We can type in W50 and H sub. You see, we have to move here. As you can see here, it's upside down. This variable is here, and this is here.